Okay, so we spoke Thursday that T in the interest formula is time in years, right? Okay, so we have I equals principal times rate times time, and T is years. Okay. If I want to know how much an account earns in some amount that's not perfect years, I have to make it a fraction. So I have my principal is 2,000. My rate, I move 2 places to the left, so 0.052. And my time is 7 months. Well, 7 months out of 12. So there's 12 months in a year. But I know how much you guys love fractions. No? Really? You don't like fractions? So I'm going to show you the other way to set it up. You can multiply 2,000 times 0.052 times 7, then divide the whole thing by 12. And then it's not really a fraction, it's a division. Okay, so we'll do that multiplication across the top. So 2,000 times 0.052 times 7 gives me 728. Divided by 12. And I get 60.6 repeating, so I'm going to round that to 67. So it would be $60.67 in that 7-month period. Does that make sense? Have kind of the backwards approach. We know the interest, we know the time and the rate, but we want to find out how much do you have to deposit to earn that much interest. So same formula. But this time I know interest. What I don't know is principal. Rate is 0.05 because again I have to move this 2 places. And then time is 2. Okay, so I'm going to multiply 2 times 0.5, and I think that's 0.05 times 2 is I think 0.1. Ha, yes, I can do that in my head, yay. I'm going to put it in front of the P because that just is how it looks prettier. Then I divide both sides by 0.1. And I think that's 10,000. I'll just double check myself. Yes, it is. So for this example, if you wanted to earn $1,000 in 2 years, you'd have to deposit $10,000. We have interest, we have interest rate. We have his balance, so that's going to be his principal. And we want to know the length of time it would take to grow to 1,000. We don't know the interest and we don't know the length of time, but we can find the interest. Okay, so the interest is going to be that 1,000 minus the 910. That's how much interest he'll have to earn to hit the 1,000. Does that make sense? So it'll be $90. And then we want to find out how long that'll take. So again, we use, anytime you see the words simple interest, it's going to be this formula. So I want $90 to equal $910 times 0.041, and I don't know what T is. So I don't know how long that'll take. So I have 90 is equal to 3731 T. I'll divide both sides by 3731. So 2.4 years. And you can leave that as a decimal. I don't need you to figure out how many months exactly or anything like that. Just 2.4 years is fine. Here we've got somebody investing $5,000 in simple interest for 5 years, and we want to know the rate. So we've found principal, we've found time, now we're finding rate. We want to know how much interest. We want 6,000 at the end, so we have to do 6,000 minus 5,000. So we want our interest to be 1,000. So again, same formula. 1,000 is equal to 5,000 times some unknown r times 5 years. And 5 times 5,000 is 25,000.
What is the on?
Rate? Yeah, that's the interest rate, so it's the percentage, but always as a decimal. So we do that 1,000 divided by 25,000. That's that. Would help. Okay. So it's going to be 0.04. We want to know what it is as a percentage, so to go to a percent, we'll move 2 places this way. So 4%. Simple interest is only based off of what money you put into the bank, your own deposits. Compound interest is based off of the money you put in the bank and accumulated interest. So you're earning more because if you put $100 in the bank and then you earn $20 in interest, the next time they calculate your interest, it's not going to be counted on that 100 again, like simple interest. It's calculated on the 120. And then the next time you earn interest, it's calculated on maybe like 140. So it builds and builds and builds. So let's do some vocabulary. So with compound interest, with simple interest, like I said, you deposit money, you deposit $100. And when they calculate your interest, they calculate it on $100. The first year, they calculate it on $100. The second year, the third year, the fourth year, provided, of course, you haven't put any more money in, if you only ever put that $100 in. But that's the only thing they ever calculate your interest on is that $100. With compound interest, they calculate your interest on the initial $100 you put in. So the first year, they would calculate it on the $100. And then the second year, they would calculate it on, let's say, 110, because maybe you earned $10 of interest. And then the third year, that second year, instead of earning $10, you might earn $11, because that $10 made a dollar difference. So then the third year, they wouldn't calculate it on $100, they'd calculate it on 121. And so every time they do the calculation, it's calculating on a higher number because they're counting the interest that they've already paid you. So compound interest earns you more money than simple interest does. And then there's different times that they'll do it. Annual compounding occurs once per year. It's usually at the end of the bank's fiscal year. And a fiscal year is different than a calendar year. A calendar year goes from January to January. Fiscal years usually are set by the bank. Some of them might go from January 1st to December 31st, but some of them could go from like May to the end of April. It just depends on when they do their budgeting. Like our school calendar year goes from August to July. Yeah. Specified, yeah. So semi-annual compounding occurs 2 times per year, so it's every 6 months. And it's not January, June or something. It's whenever they decide the 6 months are. It's twice a year, but it's a set time twice a year. So if they do it January 1st and say July 1st, or whenever they set it. Quarterly compounding occurs 4 times per year, so that's every 3 months. Then there is monthly compounding, which would be 12 times per year. And then you have daily compounding where the bank calculates the interest every single day at the end of the business day. And that'll either be 365 times or 366 times per year because of leap years. But for our calculations, always use 365 unless you're specifically told this is a leap year. So we'll just always assume that the days of the year are 365. Okay, so the bank compounds the interest. That's when they do the calculation. And then they credit the account the interest. And those are not always at the same time. If they're doing annual compounding, so they're only calculating once a year, they'll credit usually the same day. But if they do semi-annual or quarterly, sometimes they'll only credit at the end of the year. So they'll do the calculations 2 or 4 times per year, but then they credit it at the end. If they're doing daily compounding, they usually credit it at the end of the month. So they'll calculate it every day, but they'll put it in your account at the end of the month. Just because it's less work that way. Okay, so we want to know how much interest would $1,000 earn in 1 year at a rate of 6% compounded annually. For right now, before we get into there is a formula for compound interest, but for right now we're going to use the simple interest formula to show how compound interest works. Okay, so I've got my formula. So I have $1,000 at a rate of 6%, so that's 0.06, and it's 1 year. So that's going to be 60, I think. Yay! So that first year, it's going to be $60. Now here we have $1,000 in a savings account that pays 6% interest compounded semi-annually. So we're going to have compounding that happens twice. Okay, so we have the first and then we'll have the second. Okay, on the first, she puts in her $1,000 and it's at 6% interest, but we're at 6 months. Which is the same thing as 1/2. So she's going to earn $30 in the first 6 months. Okay. And the balance at that point would be $1030. Well, then when they do the calculation for the second 6 months, it's not $1,000 that they're calculating on now. It's $1,030 that they're calculating on. Okay, so I do 1,030 times 0.06 divided by 2. So 1030 times 0.06 divided by 2 is $30.90. So then the balance would be 1030 plus 3090. Okay, and same amount, same rate, same length of time, but because they did the calculations twice instead of just once, you got an extra $1 almost. So we have the $1,000, that's PRT again. So we have the $1,000, we're at 6% interest, but we're at 3 months instead of 6. And that reduces to 1/4, so we're going to divide by 4. So it's 60 divided by 4. And I should know that off the top of my head, but I just don't right now. So it's 15. So at the end of 3 months, your balance would be 1,015. Now, let's go ahead and do the So this would be the first one. Quarterly happens 4 times. So we're going to do all 4, just so you can see what your balance at the end of the year would be as compared to annually and semi-annually. Here I'd have 1015 times 0.06 divided by 4. Which would give me 1523. So the balance at that point would be 1030.23. Now at the end of 6 months, this is 6 months. On our last example, we were at 1030. We've already earned an extra 23 cents. Then when we do the next one, we're not doing 1015, we're doing 1030.23 times 0.06 divided by 4. Which gives us 1545, and you add that to the 1030.23, and your balance at the end of the 3rd quarter would be 1045.68. And then when we do the next calculation, we're not calculating it again on the 1030, we're calculating it on 1045.68 times 0.06 divided by 4, because this was the 3/12. I'm just using the same thing, but I already knew it was reduced. Yes, definitely. And that's 1568. So your balance at the end of 1 year on this would be 1061.36 as opposed to 1060 and opposed to 1060.90. And no, it's not a huge difference. Bless you. I mean, it's not a huge difference, but it's $1.36. And these $1.36s add up, you know. So if you had $10,000 in there instead of $1,000 in there, it would be $13 extra. You know, so I mean, it adds up. So compounding really, yeah, and then that goes into the next year, and then it grows even faster. Yeah, this is just 1 year. In that 1 year, it made that much difference, and that was just compounding quarterly. If we compound daily, we're not going to do, obviously, all 365 calculations. But if we compound daily, when you're asked to do this kind of a calculation, we're doing the 1,000 times our rate, and our time is 1 out of 365, because there's 365 days in the year, and we're talking about just 1 day. So that's 60 divided by 365. And so we're going to earn 9 cents that day. And that'll go up daily. If we're talking about day 2, you don't have to, we're not, like I said, we're not going to do all of these. But day 2, it already went up to 16 cents. Hold on. But you can see just from 1 day to the next how much that grew. And then the next day, and then the next day. And that's going to happen 365 times. And because I know the formula, hold on, I'll tell you how much you'd have at the end of the year. Let me just, but at the end of 1 year, you'd have an extra 50, almost 50 cents. But that's the same amount of money in the bank. That's not doing any extra work. That's your same $1,000 just sitting in the bank, but it's an extra 50 cents versus, you know, just on how many times the bank calculates. So when you're looking for bank accounts, you want daily compounding. No, that's fairly standard. Yeah, and then they usually pay monthly, but just ask because it's not every account. But you know, like I said, when you're looking for your bank accounts, when you're researching which bank is going to give you the best for your money and do the best for you, a daily compounding versus a quarterly compounding is an extra 50 cents a year for this. And it's no different. You're not doing anything different. You're putting money in the bank and it's sitting there. Find the one that's going to give you the most back for it. Does that make sense? So that's the whole point of knowing how to do these, really. Is that one of the? Okay, so here we have a daily compounding account, right? And she has a balance on July 11th, and then she withdraws $200. So this is how, that's supposed to be July, not Julu, whatever, however you'd say that. This is how the bank calculates these things. They calculate your interest at the end of the business day. So at the beginning of the business day, on July 11th, we had $1234.98. And then she takes out $200. Okay. And then she deposits $34. Okay. This is the end of the day on the 11th. So this will be what number gets used for that daily compounding. And it's 0.032, and it's 1 over 365. So that means we multiply these two and then divide by 365. So she earns 9 cents that day, which does not technically get added in until the end of the month at most banks, but they go ahead and enter it for the calculations a lot of times. So on July 12th, when she starts her day, she starts it with this amount of money. And it's not a huge difference, but it is a difference. And then she deposits her paycheck. And then we use this amount to calculate her new interest. So I do 141484 times 0.032, and that gives me 45,27488 divided by 365. And so she earns 12 cents. And so for the next day, when they start her bank balance for any calculations, it would be $1414.96. That would be her balance.